Welcome to the Hydrogenation of Benzene to Cyclohexane series for Aspen Plus version 10. This video series serves as an introduction to Aspen Plus for chemical engineering students studying material and energy balances. For Part 3, a compressor block, recycle stream, splitter block, and purge stream will be added to the hydrogenation model. The recycle stream is added to limit the waste of hydrogen and cyclohexane, and the purge stream is added to prevent vapor buildup in the system. In addition, heat curves and unit sets will be introduced in this video. After opening the Aspen hydrogenation model from its last saved point, switch to the main flowsheet. In the model palette, under the Mixers/Splitters tab, select an F-split block and drag it on to the main flowsheet. Similarly, under the Pressure Changers tab, place a compressor block onto the main flowsheet. Next, right-click on the 8-top stream and hover over the Reconnect option. Select Reconnect Destination and click once on the red inlet arrow of the F-split block. Then, click the Material Stream icon and add an outlet stream from the F-split block and streams connecting the newly added blocks. Next, cancel Insert Mode and begin naming the newly added streams and blocks. Name the B1 F-split block B7 Split. Next, name the S1 stream 10 Purge. Then, name the S2 stream 12 Recycle. Finally, name the B2 block B8 Compressor and stream S3 to 11 Mix HP. Next, the newly added blocks must be specified. In the navigation pane, in the Blocks folder, double-click on B7 Split. Specify the split fraction value for the stream 10 Purge to be 0.08. Then, open the B8 Compressor folder in the navigation pane. Specify the type to be isentropic and discharge pressure to be 23 bar. Now we will create a heat curve for the B5 cool block. Heat curves can determine the overall geometry of a heat exchanger, providing information on the heat duty, pressure, temperature, and vapor fraction of the heat exchanger. To begin, click on H curves in the B5 Cool folder in the navigation pane. Click New, let the curve number be 1, and click OK. We will let this H curve have the default specifications. Now, double-click on the H curves folder in the navigation pane. Click New, let the curve number be 2, and click OK. Next, specify the pressure profile option to inlet and then run the simulation. Click Results in the HCurve2 Specifications menu, and results for heat duty, pressure, temperature, and vapor fraction will be displayed. Switch to HCurve1 in the navigation pane, and similarly check the results. Now we will create a new unit set for our hydrogenation model. Once a unit set is chosen, all measurements of the simulation will be presented in those units. To begin, in the navigation pane, in the Setup folder, select Unit Sets. Click New and enter ENG-CP-SIG as the ID of the new unit set and then click OK. As a starting point, we will copy the English engineering units to our newly created unit set. In the Copy From option, select ENG. Now, we can change a variable's unit more specifically. For example, change the temperature unit to Celsius and pressure to PSIG. To implement our unit set, Go to Specifications in the Setup folder of the navigation pane. Then, change the global unit set to our new unit set and run the simulation. To check for our corrected units, select the results of the form mix hot stream. There we can see that temperature and pressure are in units of Celsius and PSIG. The rest of the simulation will be done in the default MET-C bar unit set. To easily change unit sets, switch to the Home tab near the top left of the program, and then in the Unit section, switch to MET-C bar. Notice the variables will be reverted back to their original units. Finally, save the model. This concludes the third video of the Hydrogenation of Benzene to Cyclohexane series for Aspen Plus version 10. Please continue to video 4, which will introduce the usage of a sensitivity analysis.